Part B, we're asked to use the trapezium rule with the values taken from the table to estimate the distance in meters travelled by the train. Now, the trapezium rule effectively is splitting the area underneath the curve into trapeziums. So you can see here I've done this, right? You don't need to do this, you don't need to actually draw them in, but sometimes it's helpful to see that we've got trapeziums there. And it says that they want the distance from 35 to 50 seconds, okay? And they've given these time intervals here. So that's why I've drawn lines of 35, 40, 45 and 50. And it creates these strips. Strip 1 there, strip 2, strip 3. If I turn it around, you can see why I put those arrows on. You can see then that we've actually got trapeziums here, okay? Because they parallel and they've got a pair of parallel sides. And I've drawn that line in there. So you've got trapezium 1, trapezium 2, and actually we can think of that as a trapezium as well. I know it is actually a triangle, but the trapezium formula works for it as well. Okay, so we just simply use the formula for trapezium, okay, which is there, okay, given to you on page 2 on the formula sheet. And we substitute in the values. So remember now, your A and your B are the two sides that are parallel, yeah? Okay. And your H is the height between them, okay? So if I work out area 1 here, well, my A in this case is this length here, which it says in the table is 3.1. Add then this length here, which it says in the table is 2.4. The height between them then for the trapezium is, let's have a look, what is it? Of course it's 5 seconds, isn't it? It's the distance here. So I just got to work that out, so I can use my calculator in this case. And I get out 13.75. So that will be meters, okay? The area under the curve gives us the distance in meters. So do the same then for area 2. Half 2.4 will be that distance there, and then this side then opposite it will be 1.5. Times it by the gap between them, which is 5, so I'll do that on my calculator. So I get 9.75 meters. Area 3 then, well, this is like a triangle, but you can think of it as a trapezium. You've got that length there, which is 1.5, and this other length there, which is 0. So 1.5 plus 0, times then the gap between them, which is 5. If you did the triangle formula there, it would be the same. Get 3.75. So all you've got to do then to get the total distance is to add them. So total distance (27.25 meters). Okay, it is an estimate again, right? Estimate the distance because the distance is found by working out the area underneath the curve, and I've worked out the area of these trapeziums. But if you notice here, okay, I've drawn lines here to complete the trapezium. It's not quite the curve, isn't it? Okay, so there's a little gap there. So it's not perfect, but it's a good estimate for that distance.